Hi everyone, this is Kanika and in this video we'll be discussing about TCP IP protocols, and if time persists we'll discuss further about IPv4 and IPv6, which are the two generations of IP protocols. So let's get started with TCP IP protocol. So TCP IP stands for Transmission Control Protocol or Internet Protocol. So what is this TCP IP? It provides a set of rules. And conventions which tells us that how devices would communicate over a network and how they would communicate with each other, right? So it is a set of rules and conventions which tells us that how devices communicate over a network with each other, right? Okay, so this transmission control protocol is organized into some layers, as you can see in this image. So these are the 4 layers of TCP/IP model, and each layer has some set of defined protocols like these. You can see these are the defined protocols. These are the protocols in every layer, and which we'll be discussing in detail, and we'll discuss functions and protocols associated with each layer in detail. So let's start with the very topmost layer, which is application layer. Okay, so before heading to the discussion of functions of application layer, let's first understand what is application layer. So imagine this layer as a friendly neighborhood where, suppose consider there are two programs. First is email, and then there is suppose other is web browser, and these two are communicating. So this is a friendly neighborhood where these two apps or several other apps can communicate with each other, or you can assume it like a postman that delivers messages between your computer and to the applications you use. I hope this is clear. So you can assume application layer as a friendly neighborhood, so where these two programs are communicating with each other, or you can assume it as a postman which delivers messages from your computer to other apps. So application layer is a top layer where user applications and network services interact. So it provides a base where applications can interact with each other. So it provides a means for software applications to communicate over a network. So that's why I was saying to assume it like a postman which delivers messages from your computer to other applications, right? Now let's discuss the protocols which are in application layer. So first protocol is HTTP protocol, which is hypertext transfer protocol. So this protocol is used for web browsing. Next protocol is FTP protocol, which is file transfer. This is hypertext transfer protocol. This is file transfer protocol. As the name suggests, it is used for transferring of files, right? Next is SMTP protocol, which is simple mail transfer protocol. Let me write it down. Simple mail transfer protocol, and this protocol is used for email. Next one is DNS protocol, which is domain name system. This protocol, domain name system, it translates domain names to the IP addresses. So there are few other protocols like Telnet, which is used for remote access to computers. SNMP, this is simple network management protocol, and this is used for network management, right? So these are the protocols which are involved in application layers: HTTP, FTP, SMTP, DNS, Telnet, SNMP. Now let's discuss transport layer. So this one is the transport layer which we will be discussing. This layer, transport layer, few of the protocols we'll also discuss along with it. So next layer is transport layer. So transport layer manages end-to-end communication between two devices. So imagine this layer as a traffic manager which ensures that each car is reaching to its destination in right order. So assume that we have several cars, right? Just ignore this drawing. So we have a traffic manager which will ensure that every car reaches its destination in the right order. So if a car is missing, then the traffic manager will resend that car to its destination. So by this example, we can correlate that with each car, this traffic manager is ensuring that each car is reaching its destination. That means this transport layer ensures that each data packet reaches its destination in the right order without getting lost. Okay, and if the data packet is missing, then this transport layer, just like the traffic manager resends the car to its destination, this transport layer will resend this data packet to its destination. So this was the purpose of the example. So I hope this is clear. So this transport layer manages end-to-end communication between the devices. Next is, it ensures reliable and orderly delivery of data. Just like this traffic manager was ensuring that every car reaches its destination in the right order and without getting lost. So just like this data packet, just like the traffic manager, transport layer also ensures reliable and orderly delivery of data, right? Okay, next now discuss its protocols. So the first protocol is UDP, which is user datagram protocol, and the second one is TCP, which is transmission control protocol. Okay, so let's first discuss this TCP. This TCP protocol is more reliable. This is reliable. This is connection oriented, whereas this is connectionless. This is connectionless protocol and this is unreliable. So why we are saying that this is reliable, this is unreliable? Because this protocol, TCP protocol, it ensures data delivery. It ensures that the packet has reached its destination. So it ensures data delivery, whereas this is used for faster communication. So whenever we are streaming live, so we will use UDP protocol because we will need a faster communication. We can also opt for TCP in that case, but UDP would be a greater approach. So TCP ensures that the data packet has reached its destination, whereas in live stream we are not concerned with whether the packet has reached or not. We are very much concerned with the streaming. So we will use it for audio or video streaming. Okay, so next layer is internet layer. This layer is also known as network layer. What is its function? Its function is it handles logical addressing. What is logical addressing? It is IP addressing, and it handles routing of packets between networks. Okay, so to understand this internet layer, let's take an example. Let's consider this internet layer as a data guide. So what this data guide will do? This data guide will guide your data packets. So these are data packets. It will help these data packets to find its way across the internet. So what this internet layer will do, it will give each data packet an address which is known as IP address. So that is why we are saying that it handles logical addressing. So it will give each data packet an address and decides the best route for it, right? It's like a GPS for your data. So you can consider it like that way. And it handles routing of packets between networks. Routing of packets, that is why we are saying that it finds the best route for your data packet, right? Next is protocols. Protocols in internet or network layer. So the first protocol is IP protocol, which is Internet Protocol. Next one is ICMP protocol. So internet layer is for addresses and it routes packets. That means it finds the best possible way for a data packet, routes packets, and then you can say across networks also, across networks. And then there is ICMP protocol, which is Internet Control Message Protocol. And this is used for error reporting, and you can also say diagnostics. Okay. Next protocol in internet layer or network layer is ARP protocol, which is Address Resolution Protocol. So this protocol, what this protocol does, this protocol maps IP addresses to the MAC addresses. So this is IP address is logical address and MAC address is your physical address. I hope this is clear. If there is any confusion, please let me know in the comments. I will make a detailed videos on logical and physical address as well. Alright. There are several other protocols in internet layer, but I think these are enough for you to understand for now. So the next layer is data link layer. So what happens in data link layer? You can consider this data link layer as a postal system. Postal system, like in older days there were letters and we have a mailbox at several other areas in our local area. So you can assume that there are several letters, and here each letter we are referring as data packet. So this postal system was used to take care of the physical part of sending and receiving letters. So here also data link layer is useful, is responsible for sending and receiving of data packets. So these are data packets. We are referring letters as data packets. So this data link layer also ensures that every device gets the right data packet by using the local addresses. So it will make use of local address and it will make sure that every device gets the right data packet. Right, so it works like this way. So there are several data packets and this layer is responsible for receiving and sending of these data packets, and also it will make sure that every device gets the right data packet by using local address. Right, so that is why we are saying that it is used for physical transmission of data. Why? Because this layer, data link layer, is responsible for sending and receiving of data packets, and then we are saying that it handles addressing within the local network. That means this layer makes sure that every device gets the right data packet by using the local address. Right, okay, now let's move on to the protocols. So the first protocol, very common, Ethernet. This is the LAN protocol. Next is wireless protocol, again Wi-Fi. This is wireless LAN protocol. I hope LAN, you all know, local area network. It is a network of computers within a local area. Right, this is LAN. So Ethernet is a LAN protocol and Wi-Fi is a wireless LAN protocol. Next there is PPP, one second, yeah, which is point to point protocol. So what this is used, it is used for dial-up and some broadband connections. Next one is frame relay protocol, which is packet switched WAN protocol. So we have discussed all the 4 layers of TCP/IP model, and we have discussed all the protocols associated with every layer. If you have any doubt, you want any kind of discussion, please let me know in the comments, or you can send me an email on my email address as well. Let's discuss more about IP. So IPv4 and IPv6. Let's discuss about this. So we have IPv4 and IPv6. So IPv4 and IPv6 is Internet Protocol version 4 and Internet Protocol version 6, as you can see in this image as well. So these are the generations of Internet Protocol, and it is used for identification and location of devices. Like we saw in data link layer was responsible and was ensuring that every device gets the right data packet. Why? Because of the logical addressing. So it is used for identification and location of devices on a network. So by using this IP address, we were able to ensure that every device gets the right data packet. So what are this IPv4 and IPv6? So from this image we can see, let me zoom in a bit. So from this image we can easily differentiate between IPv4 and IPv6. So for IPv4 is a 32-bit address, whereas this is 128-bit address. And the possible number of addresses are 4.3 billion, and here 340 undecillion, right? So you can see the example as well. It is containing IPv6 is containing hexadecimal numbers also. So let's jump into detail for IPv4 and IPv6. So first IPv4. IPv4 address format, as we just saw, are 32-bit numerical labels, and these are typically expressed in the decimal format, and these are 32-bit divided into 8 bits of octets separated by a dot. For example, in this case 192 and then 168, then 1, then 1. So these are separated by dots. These are divided into 8 bit of octets, right? These are separated by dots. And then let's dive in more about its address space. So it uniquely provides 4.3 billion of addresses approximately, right? But due to rapid growth of internet, we were needing more IP addresses, more unique number of IP addresses, which this IPv4 was not able to provide us. So due to rapid growth of internet and exhaustion of IP addresses, so that is why this IPv4 addresses got exhausted, and then IPv6 was introduced to overcome this limitation. Which limitation? The limitation was that internet was growing so rapidly that we were needing more unique addresses, more number of unique addresses, which this IPv4 Internet Protocol version 4 was not able to provide us. That is why we have to introduce IPv6. So let's see the example of IPv4. We have seen that it is divided into 4 8-bit of octets. 8-bit octets. And here also, but this is example of public IP address, and this is used for local network. Next, its example usage. So this IPv4 can be used in a home network wherein a device such as computers, smartphone, printers are assigned to IPv4 addresses to communicate with each other and access the internet. And business and IP service providers use IPv4 to manage their networks and provide common connectivity to users. So basically it is used by business and IP service providers, and it can be also used in a home network. These devices can communicate with each other and access the internet, right? Okay. So IP version 6, its address format, we just saw that it is 128-bit hexadecimal numbers. So this is a 128-bit hexadecimal number separated by colons. So you can see there are colons also in between. So these are 128-bit hexadecimal numbers. You can see it is including 0DB8, 85A3, and it is separated by colons. So these are 128-bit, and IPv4 was 32-bit. Since we were requiring more number of IP addresses, which IPv4 was not able to provide us, so this has longer address length, and it allows exponentially larger number of unique addresses compared to IPv4, right? Its address space. So the range it provides is 3.4 into 10⁻38 approximately. As we just discussed that this was introduced to accommodate growing number of devices connected to internet. So this vast space was introduced to accommodate the growing number of devices connected to the internet. So this point we have also already discussed. Next is the example of IPv4. We just saw these are 128-bit hexadecimal, and then these are commonly used for linked local addresses. In today's date, IPv4 is in use also in parallel with IPv6. So IPv6 is used in parallel with IPv4. So it is not completely depleted. So IPv4 is not completely exhausted. It is used in parallel with IPv6, and this is known as dual stack configuration. So many devices in a network are configured to support both the IP versions like IPv6 and IPv4, and this is known as dual stack configuration. So let's further dive into this term, dual stack configuration. So what is this dual stack configuration? Dual stack means that we can use both IPv4 and IPv6 simultaneously, right? So we can use both IPv4 and IPv6 together, and many systems, routers and networks. So many systems, devices, routers, networks are configured with this dual stack configuration. That means they can support both IPv4 and IPv6, allow them to use both IPv4 and v6 simultaneously, and this transition strategy ensures compatibility during coexistence of both the protocols. So in summary, if we want to quickly list out what we have discussed about IPv4 and v6, so we have discussed that IPv4 and v6 are the protocols that enable communication between devices on an internet, and IPv6 was introduced to address the limitations of IPv4, as we had just discussed, primarily the exhaustion of available addresses by providing a much larger number of address space, right? And as the internet continues to grow, the adoption of IPv6 becomes increasingly important for us to ensure continued connectivity and support for expanding number of connected devices. So we have discussed about the TCP IP and the two versions, IPv4 and IPv6. If you have any kind of doubt, please ask me in the comment below, or you can email me as well. And thanks for watching. See you in the next video. Bye for now.